Hello, everybody. So, as Patrick told, the title is Pwning the Banks and what has happened on the playground after that. Briefly about myself, I work as a lead security specialist in Nixu, and I've been trying to learn penetration testing since '99. The trade is actually about poor luck. And the more I learn, the luckier I get. And that's, well, saved my projects a couple of times. Anyway, I was listening to the keynote and actually the opening talk as well, and they were talking about pretty much the same thing as I am, past, present, and maybe future. And I'd like to start with a disclaimer. First of all, I do this with a contract, so totally legit stuff. And in general, we are not allowed to talk anything about our assignments. So no need to come asking about any specific on any other project that I've done. Even in the customers, there's only a few people who are actually hearing about the tests, yet alone seeing the reports. So basically, in some cases, they are thinking that they can just publish the report afterwards, but when they see the actual findings, it's usually classified after that. However, I do have one case that I can talk about, as Patrick told, happened quite a few years ago, and I was doing a penetration testing for a bank, and they wanted the whole network to be tested. Time allocation for the assignment was 2 weeks, and from everything I can tell, it appeared that the customer actually wants to assure others that they are secure. And well, after working for 1 week and giving a intermediate report, the assignment was actually deemed complete, and they did not even want to return report at that point. Anyway, here we go about the engagement. It was total black box. I was given only C-class network as target. I was working over the internet to the other side of the world, actually. And I had no user accounts, no documentation, no real limitations on the audit, which was very good, but they didn't want any disruption on the services. So in that sense, I had to work somewhat carefully. And sadly, no monetary transactions were allowed on this assignment. Here's my assumption of the target. I was thinking that there would be DMZ with some public services and then internal network with private IP addressing. And this is pretty much where I started from. And because in this case there was no need to stay under the radar, I just started with a full-blown scan, which in some cases is just okay. In one case, when I was actually working at one bank's premises, when I booted up my machine, it took them 5 minutes to turn off my Ethernet port from the switch. And then a few minutes more, there was a guy checking on me on my door. So some cases you need to play low. In this case, I just started with a full-blown scan with no delays or anything in there. Basically, I started with a quick scan with just to map out some easy or fast services to be found, and let a full-blown port scan run in the background. And then I did a vulnerability scan based on the initial port scan results. And the initial results were actually quite disappointing from my point of view. there was only one TCP port open, which was HTTPS, and everything that I could see was up to date. So required quite a bit of effort to even think about venues, how you could actually get inside. And moreover, Nessus, that was the vulnerability scanner that I used at the time, reported only low-level findings. Nothing critical, nothing high-level, just something that you wouldn't think that would help you at all. The web application that was within the HTTPS port was basically a login page to the web bank. And well, no user accounts, so I couldn't see anything further. I ran full web app scanning against it and tested some other stuff, and basically that turned out to be nothing. So initial reconnaissance was quite interesting. Here it's showing very poorly, but this is the most interesting finding on the vulnerability scanning, which is reported as risk factor none. So, well, anyway, this was what I used or started to using to gain some access to the target. So, the finding was about they had enabled Microsoft front page extensions, which is something that some of you might remember from over 10 years ago. And basically, it's a bad idea to allow somebody from the internet to update your web server. Well, happens every day nowadays still, but with different methods. Anyway, at this point I had to start learning completely new tools for myself, which was Microsoft front page. And then I had to start learning Visual Basic, or Visual Basic script to be exact, which actually was something that I had done something with all over, because in the early 2000s, whenever you had script, language VB script, i.e. executed it no matter where it was. So at that time it was very easy to do cross-site scripting type of attacks with just having VB script anywhere, no matter whether it made sense or not. So one more trick that had to be done was on the script that I wrote to make sure that it is run on the server side, and that's the run at server. And then just simply create a VScript shell and run command in there. And well, this is the beauty I was able to write and then upload to the IIS server. And then when I was accessing the page, my command got executed, which was kind of nice. I did have some challenges. I uploaded some other binaries because at the time I had actually never heard about web shells, and basically I wanted to have proper access to the server, and trying to write this stuff in VB script wasn't really what I wanted to do, so I tried to use netcat.exe, which is a telnet-like tool that you can use creatively. And I had some trouble uploading the binary because it always turned out to be 0 size at the server. So I tried some other binaries, and some of them were uploaded properly, some of them had the size 0. So basically there was antivirus software blocking some of the binaries, all of the interesting ones, so to say. Then, of course, I had to get the shell, and for that I did some trivial changes to the netcat binary, so that at the time antivirus was pretty much working with signature-based detection, and changing some critical parts of the exe was enough to fool the antivirus. Then on my own computer, I opened up the IP tables and put another netcat to listen on port 443, which is quite safe usually when you are getting a reversal from somewhere. Next step was to use the described VB script and just run the netcat exe that modified netcat exe that I was able to upload there, and just start a command shell with it and give the input-output to my network host. And this gave me a nice interactive shell, which was a good step forward. Now I was able to do pretty much anything on that single machine with regular user privileges or limited user privileges. Then trying to think of ways to go forward. One common thing is to try to grab some passwords, because they tend to be used all over, and you can usually, if you can grab passwords from one system, it's way too often possible to use those credentials elsewhere. So for this, I used pvdump. Don't remember the exact version of it. There's a whole bunch of different versions of this tool, and they have evolved between Windows changes and so forth. But basically, you can grab the password hashes from some database and decrypt them with syskey or Windows memory directly if you have sufficient privileges. So basically, I would have needed administrator power on the machine to be able to grab the password hashes directly from there, and that was not available for me. But in Windows, at the time, there's the SAM database that contains all the secrets, and it's locked while the operating system is running, so one can't access it. But there was a backup of it done automatically, and with the backup you can just use the pvdump and grab the encrypted hashes from there. So that was a successful way to get some more information about the target. Windows is or was quite interesting in the sense that they had improved the hashing algorithm. So they supported NTLM v2, and that was actually something that they basically used. But on top of that, they stored the old Lanman hash as well, which is very quick to crack even at the time. So Lanman hash supports 14 character passwords, but it treats them in two parts. So it's actually 7 characters and 7 characters. So many people actually at the time, because the password policy said that password has to be 8 characters, they put 8 characters in it, and it was actually 7 characters and 1 character password. So quite a few passwords were whatever, 7 characters and then some special character at the end. So usually it was enough to crack the uppercase letters and numbers, and then for the last part, special characters included. But anyway, even full cracking was quite fast, some millions of tries per second, and lacking all the lowercase numbers and having this short password was actually very, very easy to obtain the administrator password from there. At this point, I was able to check out the environment, and I was trying to learn how the DM set was laid out and what was available there. And I started to looking around, scanning from the DMC to the DMC, and then trying to figure out where the internal network was. So it's kind of pivoting using the netcat command to scan TCP ports on the local network. I use this kind of short script to loop through the hosts within the C class, and then some specific ports, obviously a few more than is listed here, and using the real IP addresses instead of local host. So with this method, I saw a couple of Windows boxes, and then I saw one telnet that turned out to be a Cisco router. However, nothing generally easy and trivial didn't work there. So in Cisco, it was actually quite common that you could grab some configurations out of it using SNMP, or default credentials were also surprisingly common at the time. But these didn't fly. So this is my current understanding of the network. So I saw some backend systems and the web front on the DMZ, and then there was this rogue router that I had no clue why it's there or what it's doing. But when looking forward, I used PSExec, that is a tool from sysinternals, and was able to run commands on other Windows machines on the same network. This required me to have the credentials from the previous password cracking, or it could support pass the hash, which is basically in Windows environment, they use hashed form of the password, so to say, to authenticate our network and do things. But it's kind of stupid, because you can just use the same hash and use that as a password, basically, to log into remote servers. And so there's no key exchange or anything going on. Then I was able to check out the files on different machines with Samba, just natively, and then of course using the netcat to access other TCP-based services. However, there was no way to get into the internal network at all. I tried to look for it from every machine I could reach within the DMZ, but none of them were able to talk to the internal network. So I really needed some kind of breakthrough to get any access to the final target. I looked into the Cisco router that was there. So it was actually a Catalyst, which is a rack-based modular router, and you can put switches, routers, firewalls in the same rack, and they are kind of single entity, but each of the modules is doing their own thing. And it's actually quite common with telco routers and some blade servers to have similar functionality. What I did next, I logged into the router module with Telnet, and actually I forgot to mention something in here. So when I was looking into the DMZ hosts and going through whatever they contained, there happened to be a log file from a terminal software, and some administrator had used that terminal to log into the Cisco router, and had enabled full logging, so it actually contained the credentials for the Cisco router as well, which was very lucky for me. And when I was able to log into the router, then I just enabled more power with the password leaked, and jumped into the CutOS, which is an operating system on the actual rack. So the rack is running CutOS, and the modules, individual modules, they run iOS. And from the CutOS, by design, you are able to access the console of every module within the Catalyst. So from there, I just opened up the console for the firewall module, and they had used the same password on the firewall as with the router. So that means that I now had power within the firewall to do how I please. Well, I kind of had to change the game because everything from external to the internal network was blocked. So I added a new firewall rule that allowed my IP address to connect to the internal network, which was actually part of the C-class network. So they had split the C-class so that the DMZ had some of the IPs and the internal network had the rest. And writing carefully a new rule there, I allowed some ports for myself to gain direct access to the internal network. Last thing was to commit the changes so they would actually go into use. I did a quick sweep or enumeration of the internal network and used, for example, SMB null session to grab more information about the Windows domain. And for this, there was some tools like enum or winfo. And this is somewhat common that is available or used to be available in the Windows. So basically, the service accounts are allowed to query different Windows systems for information, and the network works with the null session. The internal servers, they were using RDP for logins quite heavily, so I was able to connect to the domain controller with the same credentials that were used on the isolated servers on the DMZ. So quite a few mistakes in the system administration practices there. So up to this point, I had deducted that the network was pretty much like this. So the router and firewall were on the same CutOS, different modules. And then there was the DMZ with some backend services. And then the internal network was a Windows network with some VMS machines there as well. This was the end of the first week. I reported the findings so far. Obviously, I had reported the initial compromised hole immediately when I discovered it, but the customer at that point wasn't really interested. However, at this point I started planning on what to do next week, so I was intending to go for the internal banking applications and then take a look at the VMS that are actually running the back end of the banking software. And unfortunately, at this point, the customer said that this is enough. We do not need any more information. So basically they were hoping to get a green report saying that they are all secure, but I failed to deliver that. Now when thinking about how things have changed since then. In general, more banks are actually interested in security, and this pretty much shows everywhere and is obviously a good thing. However, many or most of the audits actually concentrate on specific targets. So it might be a single web application or single API that they want to be tested. And this limits the scope way too much. It's quite common that the neighboring systems are giving you quite a bit of information always in, and limiting the audit scope is not that wise. Anyway, in some cases the red teaming term is used, and then this usually means what pen testing used to mean, that you get a wider scope and more means, and you might be able to do social engineering and phishing or different attacks to gain the initial compromise. Also, one thing to consider is that legislation and privacy issues might actually be a big hindering factor. So, for example, in Finland, it takes quite a bit of effort to get to be allowed to do social engineering attacks against employees. So there's quite a bit of negotiations between all the employees and companies and all that. So this depends on different countries, whether you can easily do it or not. And I think, was it 70 to 90% of successful attacks nowadays is done actually over email. So this is more or less a guaranteed way in if the attack is done properly. And one should obviously not scope that out of the assignments. Technical measures have changed somewhat. At the time, some banks didn't use OTP at all. Some others used one-time passwords. But nowadays, it's very common to do some risk-based valuation. And if the money transaction that you are performing is uncommon or big, then the bank might actually do SMS verification or use mobile app to actually approve it. So it's not only the one-time password list that is required for the action. Actually, I did some web bank testing before the SMS verifications were common, and I was able to fool the server side to believe that my one-time password was the victim's password. And well, somehow the victim's account was terminated and the money was transferred to my account. So this is actually the only example that I've actually gotten some money out of these assignments. Too bad it was a colleague and I had transferred the money to his account first, but fun anyway. Then, of course, there's some fraud detection mechanism, others in the backend systems that might stop some of the attacks, and services are tried to be isolated more and more. In general, I could say that the security has improved quite massively in different product and environments. For example, Windows system has changed quite a lot. For example, they do not allow the amount of information with null session, and as far as I know, the latest Windows versions don't even allow that at all. However, many of the tools used back then are still the tools of the trade nowadays. For example, Nmap and Nessus are good tools for the task. Well, Nessus is commercialized instead of being open source, as I think it was at that time. And well, many of the attack techniques rely on designed functionality nowadays, even more than back then. For example, the PSExec is still the same. You can use it to run commands on Windows environment. Then one consideration about the passwords. Basically, cracking the password is no longer as necessary as it was back then. And this is due to the new techniques of pass the token, and well, pass the hash as well, where you either pass the hashed password or a service token, Kerberos token, and that gets you access to different machines. However, password cracking is still very, very useful. We are multiple times faster nowadays than back then. There's new techniques to crack passwords, for example, rainbow tables, and then we can utilize GPUs or multi-core machines or even cloud to crack the password with Hashcat, or John the Ripper supports this as well. The reason to actually crack passwords nowadays is to detect or exploit password reuse. So as lame as it is, this is a very common way to many systems within a network. And also the hosting providers, they often use the same credentials between different customers. So you might actually get way too good access all over the virtual environment with those. Then if you switch protocols, then you might actually need the password. So if only remote desktop is allowed from you, then obviously you can't pass the tokens then. Windows API, basically it's pretty much the same. So the Windows environment is designed for the enterprise administration, and it's very efficient for that, but that also gives good access for the adversaries. There are some new restrictions in place, but well, within Windows domain, with proper credentials, you can do a lot more than the administrators. So PSExec is still going strong. PV-dump is no longer practically used because it's been replaced by Mimikatz, and I should have a slide about that later. And then VB script is not really there on the server side much anymore. And well, on that attack, PowerShell is really the language of choice within Windows environment. The question whether hacking is nowadays easy or hard, this is full of controversies. So basically, pen testing or hacking or compromising systems is easier than ever because there's plenty of good tools that help in the process, automate things, and productized exploits allow easy compromises quite often. However, the defenses and protection mechanism, they raise the bar a lot. So, for example, writing a memory corruption exploit is nowadays I would say takes weeks instead of the few hours that in XP time. Also, I've done some incident response and forensics, and in there, well, I can clearly say that pretty much same techniques are still used on the APTs and other attacks. quite often it's the most stupid mistakes that are exploited. For example, vulnerable WordPress sites, they might get exploited. And in some cases, we've seen that after the compromise, the attacker has waited maybe a few months even until domain admin logs in. And once they grab the credentials from there, it takes them a few minutes to pwn the whole environment. So also, even though it's very, very common to exploit the stupid mistakes, I would say, there's plenty of highly advanced attacks going on as well. And actually the recent CIA leaks have been quite interesting read in this regard. So Mimikatz, basically it's usually grabbing clear text passwords if they're available in the memory, or the hashes and Kerberos tickets also from memory. And it can do pass the hash, pass the ticket, and it can create a golden ticket that basically gives you power over the environment. In general, nowadays, these attacks or tools, they tend to be run in the memory. So this pretty well avoids antivirus detection. If we have our core components running in memory and then we load some more content from the network without ever touching the disk and do this over SSL, then it seems that antivirus is usually not able to detect anything. Also, penetration testing frameworks, there are some good ones, even free, some of them are commercial, and they integrate a lot of reliable exploits and other functionality, so they basically make these assignments quite a bit easier than what it was at the time when I described the banking compromise. Also, these tools, they do have functionality like grabbing the password and using those directly from there, tunneling traffic through one connection, or even doing so that we have a beacon running on the target system, and that is communicating over DNS or email or whatever to the attacker, and the attacker can command whenever the callback happens. And the frameworks also make it very easy for the lateral movement, especially due to the tunneling properties, so you don't have to rely on the single framework, but can use other tools as well. In Windows domain, password hashing or grabbing password hashes is actually reasonably easy if you have enough power, basically a domain or enterprise administrator or domain controller computer account. In this case, you can use DC Sync, which basically impersonates as a domain controller and asks for the other domain controllers to give me all the user credentials. And this is something that lone fighter can't really understand. How come there can be rogue domain controllers on the environment and just ask for all the secrets? But that's how it's currently working. Golden ticket was mentioned previously. This is basically Kerber's ticket granting ticket, and it is something that is used to create access to all over the domain. So once we have the password hash of the Kerber's TGT of the domain, we can offline create a new one, a golden ticket for ourselves, so that we use the hash to encrypt our ticket, and whenever we need access around the Windows domain, we can send the TC, the information, the ticket that we have asked for access to another server, and we'll be granted it. So, antivirus. Back in the day, it was obviously not up to the task. After that, there has been quite a bit of changes in the antivirus industry. So there's machine learning and other heuristic used so that they could detect attacks and malware more easily. And some of the antivirus systems use sandboxing to isolate the untrusted binaries into a playground where they can't escape. However, AV can still be bypassed. Well, the signature-based part is pretty much dead, but for example, escaping the sandbox, there are some methods for that, and the CIA WikiLeaks actually describes one method how to escape from AVG sandbox. And on top of that, there are a couple of other methods that are not really public. Then, if, as I said before, we have our code running on some process and we load PowerShell scripts dynamically and execute from memory, then the antivirus is usually ignoring this. There's a good website that describes a lot of the post-exploitation steps attack. There's plenty of information about persistence, privilege escalation, and other related topics. So they also list quite, when they describe some of these topics, they list what APT group, for example, has been using this technique. So, the detection part. Windows logging is not very good by default. So basically, there's no proper visibility of what is happening on servers or workstations, and the default settings all over are quite poor. So for example, log retention period is too small. In forensics, for example, it's very hard to analyze what happened 2 weeks ago if there's logs only for 7 hours. So this depends on the customer or whether they have actually configured the logging properly. Also, even though CMs and all these cyber operation centers are very hot nowadays, the centralized logging is still somewhat lacking. Especially the log analysis and log correlation is not that well done in general. Also, for example, when we're talking about the golden ticket, if one is using that in the Windows domain, that practically can't be seen from the domain controller logs. It's treated as a standard ticket-granting ticket, and there's no way to tell the difference between malicious use or legitimate use. And also the logs contain plenty of events that are actually not interesting to us at all, but prevent us from actually seeing the attacks in the logs. And for example, the latest Windows servers, they have was it 60 different logs that collect different data, so it's actually very hard to know them all and search for the required information from there. What about the future? Well, that's a good question. Basically, it seems that new developers enter the area and implement the same vulnerabilities again. In some places, the bar has been raised quite a lot. So, for example, Microsoft is doing actually quite good job in preventing memory corruption exploits, for example. But there are still ways to bypass the preventions. And, well, if I had to guess, I would say that the vulnerabilities and features, they do evolve, and the cat and mouse play is still going on strong in the future. Okay, thanks for your time.
Thank you, Miika, Turkia, for your presentation. There's now room for questions, so if you have one, please raise your arm so I can give you the mic and you can get your question out.
Yeah, you mentioned you uploaded a script or something in the web portal, but you said it was solely a login. Did I miss something there?
Can you repeat?
In the beginning, you were saying only 443 was open, and then you uploaded, you attempted to upload several executables.
Yeah.
There was a upload function on the login page, or?
No, there was no upload function, but Microsoft front page extension was enabled, and this is actually it's a method that, or tool that you can use to update the website. And that allowed actually anonymous access to the administration of the website.
Okay, thank you. That wasn't clear to me.
More questions? No? Then thank you all for listening to Miika. Miika, thank you. And in a couple of minutes, we'll get the next speaker.